Today's lesson is on an introduction to manufacturing processes. Products go through a product creation cycle, design through, then you select the materials, then you select how you're going to make them, process, then manufacture, then they get inspected, and then you take feedback and you use that feedback sometimes to go back and change the design, etc. Typically, the cost of a product is about 40% of the actual amount of money that the product is sold for. So anytime you buy something, 40% of what you are actually paying is usually for manufacturing. A manufacturing process is a sequence of operations and processes that are designed to make the product. You may notice that top right, there's an example. This is you may have been here at Rockland Bakery. This is a picture I threw in there from Rockland Bakery. Engineers that are involved in manufacturing could be manufacturing engineers. They're the ones that select and coordinate specific processes and equipment. For example, they're the ones who might have chosen all the equipment that they have at Rockland Bakery. The industrial engineer is responsible for the actual manufacturing system, includes the human side. So they might be the one that are making sure that it's designed correctly. And the materials engineer develops and selects the materials based on the desired materials, their properties, as well as manufacturing processes. There's a couple different types of manufacturing system designs. There's one is called a job shop. In a job shop, they're making a very small number of products. Let's say, like, for example, something that's custom. Um, typically, a job shop will make a large variety, so they may make a small number of products, but they customize it. The products will typically move through the shop to different machines, and these are general purpose machines that do lots of different things. A flow shop is one that has larger quantities of products. For example, like here, you can see this is a bottle making plant or bottle filling plant. It's a typically a production line, and it has special purpose machines. So the machine has only one job, as opposed to a job shop where the machine can do a bunch of different things. The link cell shop is one where the manufacturing and subassembly cells are connected to the final assembly. So it's very lean production. There's only one worker. And the one piece, each individual piece will first person will go to step one and do that step. Then step two, they'll make this. Step three, step four, step 5, 6, 7, etc. So this will be a very lean manufacturing, maybe one person, but they're using lots of different machines in the process. A project shop is one where the product can't be easily moved. So typically, production will be brought to a product. For example, a bridge. Okay, you can't repair a bridge by bringing the bridge somewhere. You have to go to the bridge. For example, a ship. You might have to do it in situ, or you might have to do it in a dry dock. Large airplanes, locomotives, and large machinery, you need to actually go to the actual product. Continuous processes are ones that are open 24/7. Those are typically large plants. They're ones that may manufacture oils, liquids, gases, and powders. When you drive down the in Elizabeth on the Parkway, or I'm sorry, on the Turnpike, and you can smell all those oil refineries. Those are typical continuous process factories. Lean manufacturing is an example where 100% of the good units flow from process to process. They use what they call integrated quality control, and all of the employees are inspectors. So everybody each step of the way inspects it, and then if something's bad, then they'll toss it out. There's a whole bunch of different manufacturing processes we're going to go through. We're going to go through casting, foundry, forming or metalworking, machining, joining and assembly, rapid prototyping, and some other ones. Casting and foundry, for example, is where let's say you're making a lead sinker weight, like you might have seen for fishing here. They just melt the metal down, and then they would pour the liquid metal into a mold. In one step, the materials are transformed into the desirable shape. Again, this sinker weight, for example. The parts are going to require finishing processing afterwards, maybe to make it shiny, and the excess material is recyclable. There's also a basic casting process, very similar to these chocolate molds or these jello molds that you can kind of see here. All right, you've created a mold, okay, such as these chocolate molds or these jello molds. Some of you may have cake molds at home that are very similar to that. A mold is a cavity that holds that molten material into a shape. They can be multiple use or single use, where you use them one and then you throw them out or recycle them. The material typically is heated to a specific temperature. When the molten material gets poured into the mold's cavity, then that material solidifies into the shape. For example, you melt the chocolate, and then you pour it, and then it takes the shape. Then you remove the casting or the mold, and you clean the casting, and then you finish it out, and then you inspect it, make sure it's good. Forming or metalworking can be used in making things like pipes that you see at the bottom left here. This will use material that's been cast. You can modify the shape, size, and physical properties of the material, and sometimes it's done with heat under hot circumstances, hot conditions. Other times it's done in cold conditions, cold forming. Rolling is where the material passes through a series of rollers, making it thinner and thinner and thinner with each pass, such as sheet metal, for example. Forging is where the material is shaped by a controlled application of a force. For example, if you've ever seen a blacksmith trying to make something like a horseshoe, or if you've ever been to the medieval, the Renaissance fair in Tuxedo, sometimes they'll have forgers there that are making swords. The old school swords would be made. That's an example of something of forging. And also an example of a job shop where you're just making one sword at a time, and each sword can be customized and made differently. Extrusion is where material is compressed and forced through a die to produce a uniform cross section, such as like a Play-Doh extrusion mold. You'll see pictures in a couple slides. That our 3D printers that we have here use extrusion. Wire, rod, and tube drawing is where material isn't pushed; it's pulled through a die to produce the uniform cross section. So that's how we make wires and tubes, maybe pipes. Cold forming and forging is where you take slugs of material, they get squeezed into a die that takes a particular shape. Machining processes are where you're removing material. Basically, you're cutting it away very specifically so you get a certain shape. It's going to use a cutting element, and the movement needs to exist between the part and the cutting element. The CNC or computer numeric control machine that we have in room 149 is an example of a machining process. Machining process sometimes use turning, such as in these spindles that you see in these chairs, or this type of spindles that you might see on, if you have a really fancy steps, you might see spindles like this. Basically, you're spinning a rod or a piece of wood, and then you're cutting it so that it's very consistent, same all the way around. That can be done with wood. Here's an example of how it's done with metal, and here's some more examples of how it's done with metal. It can be used to create cylindrical parts. Basically, again, the workpiece, the wood or the metal rotates, and the cutting tool is fed into the work to cut it. It's called a lathe, is the device they typically use. This is an example of a lathe down here. Okay, a lathe, they also call it a turning center. And it can include lots of different types of turning. Milling processes, this is, for example, the CNC machine, the computer numeric control machine that we have in 147. They're used to create flat or curved surfaces by removing material. If you ever seen anybody use a router to make molding, let's say, from wood, that's an example of a milling process. Cutting tools will rotate as the work piece gets secured and then fed into the tool. Mills can be both vertical as well as horizontal, and there's a bunch of different types of milling. For drilling processes, the cutting tool, meaning the drill, rotates, and then the particular material gets fed into the work. And this, for example, could be drilling or boring machines that are designed to cut holes. And you can do drilling, counter drills, counter sink, counter bore. You may have learned about that in one of your earlier engineering classes. Shearing process basically is where you're breaking unwanted material away from the part. We learned about shears when we learned about mechanical advantage back in the fall. Basically, the material gets placed in between stationary and a movable surface, kind of like a high-tech scissors. And scissors, you're going to move one of your finger, and the other one kind of stays still. So that movable surface, the blade or die or punch applies force that shears it away, kind of very similar to the way a scissors would work. This obviously is for larger materials, thicker materials. The shearing process could include an automated hole punch, okay, a squaring shear, or a rotary cutter. Abrasive machining is where you have small particles, such as like sand or something like that, that remove small chips of the material. Okay, for example, a sander, a drum, a disc, or belt sander. You may have used those in middle school. We have some in the room right next door in room 149. Disc grinders, are also examples. A tumbler. You can use tumblers to actually clean jewelry sometimes if you have nice jewelry that you need to be cleaned. Machining can include thermal as well as chemical processes. They can cut and shape materials by chemicals. In this case, they're not going to use mechanical force. They can use electricity, electrochemicals, chemical lasers, electron beams, flames, and also plasma arc cutting. Can be grinding, sawing, cutting, etc. Many processes are heat treated, or many materials are heat treated. Heat treating is basically if you're controlling the heating and cooling of material to change the properties of it. Sometimes it can make it stronger, tougher, more machinable, more resistant to wear, and make it more corrosion resistant. 90% of heat treating is typically done on steel and other ferrous meaning magnetic or iron containing metals. Heat treating processes basically, to aid in manufacturing, materials can be treated to become weak and ductile and then be retreated to provide high strength. They can also occur incidentally during manufacturing process, so they can happen on purpose and they can also happen by mistake. Joining and assembly. Okay, we've learned a little bit about joining and assembling parts. You disassembled in your last activity, you disassembled it, and then hopefully if you put it back together again, you joined it back together again. Can you think of a product that has only one part? Most products have multiple parts that are used to assemble into the finished product. Typical assembly processes include mechanical fastening, things like screws and nails, soldering or brazing, welding, or adhesives, basically meaning glues. Here's an example of screws, right? Mechanical fasteners can be screws or rivets. They use physical force to hold the parts together. Again, screws, bolts, nails, rivets, cotter pins, retaining clips, and edge design. Welding. Okay, welding uses heat, pressure, or both to permanently join parts, like in the car, parts of a car frame will be typically welded together. There's a bunch of different types of welding processes that can be used. Adhesives such as glues. Basically, they'll fill the gap in between. Okay, they can use thermoplastic, thermoset, elastomers. Joining and assembly can include soldering or brazing materials where you have metal surfaces that get bonded together by another metal alloy. You heat that molten alloy and then it flows between surfaces. Again, if you've ever done any soldering, let's say in digital electronics class, that's an example of an assembly where you're assembling electrical parts. When that heat gets removed, the molten material solidifies and then those surfaces get bonded together. Rapid prototyping is an additive process, such as like our 3D printers. Basically, you want to produce the parts directly from software. Okay, it could also include laser cutters as well. The parts can be tested depending on the material. Created parts can then be used to create a mold. So sometimes you can make the parts to actually make a mold, and then you can modify them quickly. That's the point behind rapid prototyping. Other processes, there's lots of other processes as well. Okay, testing, transportation, material handling, as well as packaging. Sometimes there are certain processes we use for specific materials, such as plastics or ceramics. Plastics in this sheet here are ceramics, let's say in this spark plug here. Plastics can be manufactured using extrusion. Extrusion is very similar to this potato extruder that you can kind of see here. You may have used one of these when you were a kid. Basically, you have a screw, or in case it's the handle that presses on the chamber that squeezes the material out. Okay. It can produce long plastic parts that have a uniform cross section. Plastics manufacturing It can also be made using injection molding. That's how typically bottles like this get manufactured, by heating the plastic, and then there's a movable plunger. Then the material fills inside it, and it gets cooled again for high volume processes. Um, Casting is where if you were to take plastic and you melt it and pour it into a mold, such as this chest piece right here. Typically, recycling and garbage cans are used using a casting process. Rotational molding is very similar to if one of these spinner toys, you may have used those as a kid, where you have a closed mold filled with a predetermined amount of plastic, and then you heat it, and then you spin it around so it puts a uniform thickness on the outside. Kind of works very similar to these spinners, where you basically put the paint in the middle, and then it kind of goes out on its own. It spins around. Blow molding is basically where you put the plastic in and then you blow air into it. Basically, you've got a solid bottom and a hollow tube gets placed between these halves and then gets heated. And then again, the compressed air is what makes the actual mold. Typically, things like coolers and these kind of cases that'll hold tools will be made from using a blow mold. You can see wheels like on child's cars. Thermal forming is where we have plastic sheets that get heated over an open mold to a working temperature. And then once they're workable, we use a vacuum to apply it to a mold, forcing the plastic sheet to take its hold. Reaction molding is where we take liquids, chemicals, liquid reactants get mixed together, and we pressurize them into a mold. It doesn't require any heat, and typically it'll cure in less than a minute. That would be kind of like for one-off, not for mass production. Ceramic manufacturing could include things like glass blowing, okay, where you heat glass to a molten state and then you shape it using a viscous flow, such as this blow mold that you see here. Somebody's blowing glass. The crystalline ceramics are shaped and heated to produce a permanent solid. Manufacturing, again, is very important. That typically the cost ends up being about 40% of the total cost of the product.